All right. Zach. Yep. See ya. Sam. Yeah. No Theodore. Jules. Aiden got you. Alicio. Oh. Elsa. Yep. Gotcha. It's all. I know I saw you. Sorry. Okay, please sign in that. Okay, thank you. On that sheet there. All right. Abby, I saw. Cameron, I saw. Evelyn, I saw. Yep. Finley. Yep. Adriana. Sorry. Okay. Shining's here. Giselle, yes. Karina, yes. Ray, yes. Albert, yes. Stefani, Skylar, yes. And Adriana, yes. Okay. Thank you for being honest, sir. Okay, so ladies and gentlemen, again, setting a timer. You have 15 minutes, ladies and gentlemen, that you can get done what you need to get done. In other words, if there's something in the lab that you didn't finish, go ahead and finish it. If you finished it but you didn't turn in your lab, please turn it in, okay? Number two, if you didn't finish the safety quiz, please get it done. All of these things are in Canvas. The Precision Lab, the safety quiz are both in Canvas, okay? Number three, if you're done with those, the Sig Fig worksheet, the Accuracy and Precision worksheet, the Metric Conversion worksheet, all things you should be thinking about, at least looking over, trying a few on, because quiz on Wednesday. Wednesday quiz, going to cover Sig Figs. Math, which we will cover today. In other words, when you add, subtract, multiply, and divide Sig Figs. Identifying how many Sig Figs in a number. Rounding with Sig Figs. Accuracy and precision will be on the quiz. Metric conversions will be on the quiz. So yes, you're going to have to go from one unit to another in a one or a two-step problem. And finally, ladies and gentlemen, measurements will be on the quiz. How do you take a proper measurement? All right? So those are the things that will be on the quiz. The time is yours right now. Please use it as you feel fit, ladies and gentlemen. If you have questions of me, raise your hand. I will be happy to come over. I don't know if you like the new seating chart, but it is the new seating chart, and I switch seats up in this class all the time. So it is what it is, ladies and gentlemen. Questions? All right, get to work on something, please. And again, if you have questions, please let me know. I will be happy to come over and give you assistance. Yes. We'll just see if there's any in the back. Please put away your phones. Please put away your headphones and things like that so I don't have to yell at you again. please remember, even if you did the precision lab, unless you submit it, I don't get to see it. So, different thing about Canvas versus Google. If you don't submit the assignment, I don't get to go back in and see it when it comes time to grade it. So, okay?
Yes. The quiz from last week or the lab safety? Okay, I have to update those, so I will take care of that and I will see what's up, okay? Okay? So I just put it there for you. Okay.
You guys have been here 1 week already. You forgot the post. Oh, again, it's a long time.
All right. A couple of things, ladies and gentlemen. Number one, if you are ever absent on the day we do a lab activity, I will put in an alternate assignment for you. Okay? In other words, I don't just want. Now, if we do a lab over a couple of days and you're here one day and you miss another, I don't mind you getting the lab information that you missed from your lab partner. But if you miss the lab completely, I will take and I will put in an alternate assignment for you. So this is an example of an alternate assignment. Now, with Google, it was very easy for me to do this because as soon as I posted it, it put it out there for all of you, and I could easily make a copy of it, or I could easily get it and I could change things. I'm finding that with Canvas, until you open it, I can't do any changes to it. Okay? I've tried a different way of doing it so that hopefully this comes to you. But what may have to happen is when you're gone for a lab, you may have to open the assignment and then I go in and then I will change it to be this alternate assignment, which I can do once you open it, but I can't do it before you open it, I don't think. I'm trying a way out today. We'll see if it works. But for example, if you weren't here, I just put in an assignment that you can do without having to have been here. Same basic assignment. It's just, okay, here's a picture of the instrument instead of having you going back and look at the instrument. Okay? So I use pictures and things like that. Maybe I'll have a video of what we did in the lab, and maybe I'll give you some data that we collected in the lab, and you just need to do the calculations and things. But I try to make it easy for you if you're absent so that you can make up what you missed without having to come in and do the lab, because I really can't leave them set up for very long because I have other classes that I'm teaching. Okay? So just so you know, this is what I will do for you when you miss a lab. All right? So I will put this in there for you just so you know. I'm trying to figure out what the easiest way for me to do this is. As I go along and as I figure that out, hopefully I'll be able to figure it out for you. Okay? All right. Today, ladies and gentlemen, we're going to talk about doing math with sig figs. The other day we talked about rounding with sig figs and how we would round to a place or we would round to a number of sig figs. Today we're going to show you why you have to do that. And it has to do with taking measurements. Okay? So we're going to do math with sig figs. There are actually 2 worksheets that are in your packet for more practice with these, just so you know. Okay? Again, we will have a quiz on Wednesday. Okay? So the quiz on Wednesday, what it will cover is it will cover, again, sig figs. So I will give you a number, ask you to tell me how many sig figs are in that number. I will give you a number and say round this number to 3 sig figs, round this number to the 10th place, round this number to the 100th place. I will give you 2 numbers and I will ask you to add, subtract, multiply, or divide them. and then report your answer in the correct number of sig figs, which we will go through today with you. I will also ask you questions about accuracy and precision. Okay? So, of these numbers, which one is the most accurate number? Of these numbers, which one is the most precise? Or write a number that is more precise than this number. Write a number that is more accurate than this number. Please remember, for accuracy, I have to give you a what? For accuracy, you have to have a target. You have to have a target or a known value. Known, accepted value, target, any of those. They all mean the same thing. So you cannot be asked about accuracy if I don't give you the target that you're supposed to be aiming for. Okay, very good. There will be a problem on there with metric conversions. Convert from this many centimeters into hectometers, something like that. I will give you the conversions that you will need. Don't expect you to memorize those. We'll give them to you in the problem. And then there will be a measurement question where you will look at an instrument, a picture of one, and you will have to determine either its precision or what place you would report to or what the measurement is. Okay? Questions on that? So you got today, you got tomorrow. If you have questions on any of that stuff, please ask. All right. With that in mind, ladies and gentlemen, open up your EISN. And I'm not sure what slide this is in your computer. Let me see if I can find it for you, ladies and gentlemen. This is slide 55 in your notes. Slide 55 in your notes is the slide that I am on right here, ladies and gentlemen. I am on 62. You need to be on 55. Today we're going to talk about why you would ever take this number and put it to the tens place. And it has to do with if you add, subtract, multiply, or divide numbers. There are rules for it. Okay. So, if we were to take this number and we were to round it to the tens place, the tens is where this one digit is. We look at the number right after it. It's a 2. So we are going to leave that 1. You are always debating, do I leave that number or do I round it up to the next higher number? That is based on the number that is after it. Since the 2 is after the 1, we are going to leave it. But what we do need to do, ladies and gentlemen, is put a 0 at the end of this number so that all of our digits stay in their same place value. In other words, this 3 is in the 10,000s place. If I do not put the 0 at the end, if I put 3,261, I have changed the value of this number. We cannot do this. All we are doing is rounding this number to the tens place. So the tens place is going to be our last sig fig. But we need a digit in the ones place so that we do not change the value of the number. That digit is a 0. Now, again, zeros at the end of a number are not significant. Which one? They are not. Not true. Not true. Sometimes. They can both be significant or they may not be significant. The difference is if a what is shown? Decimal. If there is a decimal shown, they are significant. If there is no decimal shown, they are not. In this case, I do not want that 0 to be significant. So I do not put a decimal after it. Okay? I'm just using it to hold the place. I rounded this number to the tens place. That was where I wanted the last sig fig. I put in the 0 to keep the place values where they belong. The value of the number as 32,000. But the 0 is not significant at the end. Questions? For the next one, if we were to go to the hundreds place, that is the 2. Now, the number next to the 2 is a 5. So that's going to force me to round that 2 up to a 3. So I leave the 4 and the 3 in the last two places here. I put 2 zeros. Again, not significant, but holding the value of the number, the place value of the number. Keeping that 4 in the thousands place, that 3 in the hundreds place. Questions? So, 23,612 rounded to the thousands place. The 3 is in the thousands place. The 6 after it means I'm going to round it up. I round the number to 24,000. Now, here is the good news, ladies and gentlemen. You will very rarely have to do this. You will very rarely have to round something to the thousands, to the hundreds, to the tens. But it does happen with some measurements. Specifically when you are working with beakers. Beakers are not a very accurate instrument to make measurements with. They normally read in either the tens place or the hundreds place. So again, it is possible, but very rare that this will happen. If we, instead of rounding to a place, have to round to an amount of sig figs. By the way, we have a set of rules that will tell you have to round to a place. We have a set of rules that tell you will have to round to an amount of sig figs. So if you need to round this number to 3 sig figs, the 6 is the third sig fig in this number. So the number after it is a 2. We are going to leave the 6. So we write down the 3, the 5, and the 6. But for these 3 places, which we do not want to make significant, we put in 3 zeros. Okay? That way this number only has 3 sig figs because the zeros at the end are not. Questions? The number 12,089 rounded to 2 sig figs. The 2 is the second sig fig. The 8 afterwards tells me I round it up. I round it to 1,300. 2 sig figs in that number because the zeros are not significant. Finally, 163 rounded to 1 sig fig. This is the first sig fig. The 6 afterwards means we're going to round this up to 2. We round that up to 200. Okay? We round it up to 200. Questions? All right? So there are times where we put zeros at the end of a number, but we don't want them to be significant. Questions? Okay. There are times where we put zeros into a number because we need them to be significant. Our calculator gives us a number that only has 3 digits in it, but we need to go to the hundreds place, so we have to add a 0 now. Our calculator gives us a number with only 2 sig figs. We need 3 sig figs in our answer. We have to add a 0. So now again, we are adding zeros. But both of these numbers have decimals in them, so the zeros that we are adding become significant. Okay? The zeros that we are adding become significant. So I'll put all this up there, and you can follow along as we go. The number 123, if it needs to be to the tens place, there is no digit in that spot. There is no digit to the right of that spot. So we are going to add places as zeros. So we add the tens place as a 0, so we get to the tens place. The number 16 needs to go to the hundredths place. There is no hundredths place. There is no digit to the right of it. We're going to add zeros. But the difference is, these zeros that we're adding, your number has a 1 in them. What does each one of these numbers have that our last numbers did not? Decimals. Decimals make these zeros significant. They don't change the value. 123 and 123.0 are the same value. All they are changing is the precision or the amount of sig figs. I'll let you finish typing. Okay. Whether you are rounding to a place or rounding to a number of sig figs, it is a possibility that there will not be that place or that amount of sig figs shown in your number. This is an easy fix with sig figs because we are going to add zeros to the end of our number. We are going to put a decimal in, and it will make those zeros significant. So this is how we get to the tenths, the hundredths, and the thousandths place, by adding until we get to that place. Again, 3.6 and 3.600, no change in value. All we're changing is the precision of our number and the amount of sig figs, which we are allowed to do based on a set of rules that we will teach you in a moment. The same thing here. We may round to a number of sig figs and there not be enough sig figs there. Again, your calculator doesn't do sig figs. Your calculator does math. It is up to you to determine how many sig figs need to be in your final measurement or your final answer. So, if we need 3 sig figs but our number only has 1, we add zeros until we get to 3 sig figs. Okay, now the zeros need to be after the decimal. The zeros need to be after the decimal. Why? Because then they will be significant. 4,523. If for some reason we needed 6 sig figs, we would have to add 0.00 to get this number to 6 sig figs. 264, if we needed it to 5 sig figs, we would have to add 0.00 to get there. Any questions on this? Okay. It is about to become clearer and easier, ladies and gentlemen. I promise you that. Okay? Well, at least I think it's going to become clearer and easier. How's that? All right. We're going to skip the scientific notation part right now. All right. Quickly. How many sig figs in this number? How many sig figs in this number, Abby? 3.210. 4. How many sig figs in 0.02500? Elsa? How many? You sure? No? Which 5 are significant, can I ask? You are close. What do we know about zeros at the beginning of a number? They're never significant. So this 0, even though there's a decimal here, this 0 is at the beginning. Sorry, here. So is this one. We don't count either one of them. Okay? So this only has 4. Okay? 30,205. Evelyn, how many sig figs? All 5 are. 89,000. Shining. Only 2. The 8 and the 9 zeros are not significant because there is no decimal. Giselle, 0.700. 3 sig figs. 1.02, Ray. 3. All 3 are significant here. By the way, the zeros were significant here because of the decimal. No decimal here, they are not. 690.00. Go ahead, Zach. All 5 are significant. 35,060. How many are here, Aiden? 4. The 0 at the end does not count because there is no decimal. 87.001. Go ahead, Skylar. How many? 5. You got it. All 5 are. These zeros are in the middle. They count. 9,300. 9,300, Jules. Which 3?
2.
Final answer?
All the above.
2 and 3?
Either one.
Well, correct answer is 2.
Yeah.
Both zeros at the end do not count because there is no decimal. Okay? A number in scientific notation. A number in scientific notation. Finley, how many sig figs in this number? 3. Ignore the scientific notation. Look at the number in front of the times sign. That's how you determine your sig figs. Finally, in this one, Albert, how many sig figs? All 4. The 4 of them. The 4. Questions? All right. So now there are two sets of rules for math with sig figs. One is based on addition and subtraction. One is based on multiplication and division. Let's start with addition and subtraction. When you add or subtract measurements, your answer must be no precise than your least precise measurement. So you look at the measurements involved in your problem. The one that is the least precise determines the precision of your final answer. Okay? The easiest way to solve addition and subtraction problems is to arrange the values so that the decimal points line up. Because then you will very easily see which one is more precise and less precise, and then it will be easier for you to do your math. 3 steps though. Number 1, do the math. Get the number correct. Number 2, find the least precise measurement. Number 3, round your answer to the same place as the least precise measurement. So here we go. So if we are adding 28.0, 23.538, and 26.68 centimeters, which of those 3 measurements is the least precise measurement?
28.0.
Correct, because it only goes one place beyond the decimal, correct? This goes 3, this goes 2. So your answer can only go to one place beyond the decimal. One place. That's the least precise measurement. This is the number you get when you add it together. Now we round it to the tenths place. So when we round 77.218 to the tenths place, what do we get?
77.2.
We get 77.2. That is your final answer. That is the rules with addition and subtraction. Questions? Okay. So now we take 125.206 grams minus 84.35 grams. Okay? We subtract them. Which of these 2 measurements is the least precise?
84.35.
Why?
Because it has the other number goes one more to beyond.
Okay. The number on top goes 3 beyond the decimal. The number on the bottom only goes 2. So you remember when we were talking about precision and I told you you're going to have to be able to look at measurements and see which one is the most precise? You now need to know which one is the least precise. Okay? So the bottom one is the least precise, so we are going to round that number to the hundredths place. Here's the digit in the hundredths place. What would your final answer be?
40.86.
40.86. So that is your final answer, ladies and gentlemen. Questions? Okay. All right. So, real quick, ladies and gentlemen, I think you have this slide in your notes, don't you? Good. If you need one, because we're going to be doing math for the rest of the hour, come on up and grab a calculator if you need one, ladies and gentlemen. Here's the biggest mistake people make. They worry about the sig figs before they just simply do the math. Do the math and figure out what the answers are. Then let's worry about getting it into the proper number of sig figs. As soon as you get these figured out, I don't mean round it into sig figs. I mean the simple math of adding the 2 numbers or subtracting the 2 numbers. Please tell me what you get when you add or you subtract these 2 numbers. What comes out of your calculator, please? Once you have one, please shout it out to me and let me know.
Which one, Shining? Yes, Jules. Yes, Jules. Yes, Jules.
My computer's gonna die.
Well, why didn't you charge it this weekend?
Because I thought it was out of battery.
You thought it was what?
I thought it was out of charge.
Okay. Let me go see. I don't know if I have a thing left or not.
That was really good.
Jules, you're out of luck because there are no chargers back there.
No,
I-
guys,
I-
I'm gonna die.
You will not die. Your computer
My
may,
computer's
but
gonna
I
die.
can't help you because I don't have any chargers. So I'm sorry. If someone has a charger that their computer is charged enough, you can borrow it from them. But I do not have an extra one, and the other 8 that are back there were stolen by the other teachers. So I'm sorry. All right. I'm sorry, Shining. Again, the number, please. Good. Anybody have this one calculated? This other one on the top?
1.6256 grams.
All right. The one on the bottom here. Anybody?
11.22.
Be careful. You were supposed to subtract these two. Sorry, you were supposed to subtract this one. So what'd you get when you subtract these? Anybody? 3. Good. 3 grams. And finally, ladies and gentlemen, this last one over here, when you subtract them, what do we get? Yours has a plus sign?
Yeah, ours has a
Oh, I'm sorry. I'm sorry about that. Do this as a minus. I'm sorry. Change it on yours. I'm sorry about that, ladies and gentlemen. No wonder why you're looking at me like I'm crazy. There are other reasons for it, but no wonder why. All right, what do you get when you subtract these last two? 111 point what? 95. All right. So now, ladies and gentlemen, the next thing we're going to do is we are going to take and we are going to find the least precise measurement. In this first one, which one is the least precise? The one on top or the one on the bottom? The top. It only goes to 2 places beyond the decimal. So in a minute, we're going to round this to 2 places beyond the decimal. All right, this one over here. Which is the least precise measurement here, top or bottom? Top. Only goes to 2 places beyond the decimal. That's where our number is going to go in just a second. All right, which one is the least precise in this one, top or bottom? Bottom. And it goes to 2 places beyond the decimal. We don't even have that place here. We'll show you how to handle that in a second. Finally, the last one. Which one is the least precise measurement? The top. It goes to 1 place beyond the decimal. All right, ladies and gentlemen. So now we figured out what place we want our answer to. Now all we have to do is round it. 78.708 grams rounded to the hundredths place. What do we get? 78.71. This is what I mean by at times you're going to have to round to a place. 1.6256 rounded to the hundredths place. 2 places beyond the decimal. What would our answer be? 1.63 unit of grams. Very good. Now, what do we do with this one where we don't have any decimal places? We're going to add zeros. 3.00 gets us to 2 places beyond the decimal. All right, 111.95 rounded to the tenths. What does that give us? 112.0 grams. Questions, ladies and gentlemen? So this is what I mean when I say you are occasionally going to have to round to a place. Questions at all? Okay, you want the good news or the bad news? Bad news, rules are different for multiplication and division. Good news, I think they're easier. Better news, more times than not in this class you will be doing multiplication and division. Very rarely will you be doing addition and subtraction. So this is the rule that you're going to use more often. Boom, here we go. Number 1, do the math. Same as before. Number 2, find the number of sig figs in each of the numbers that you are multiplying or dividing. So how many sig figs is in the number itself? Report your answer to the same number of sig figs as the least amount. So if you have 5 sig figs in one number, 3 in the other, your answer can only be to the 3 sig figs. That's the rule here. That's the rule. So it's based on the number of sig figs, not the place. Okay? So if we have a rectangular object and we are trying to find the volume of it, 3.65 centimeters, 3.20 centimeters, 2.05 centimeters. How many sig figs in this number? 3. How many in your answer? 3. Okay? So we are going to take and we are going to multiply these 3 numbers together. We get 23.944 centimeters cubed. That's what would come out of your calculator. Now we need to take that number and put it into only 3 sig figs, which is which digit?
9.
The 9. Because there's a 4 after it, do I leave that 9 or do I round it up?
Leave it.
So your final answer is 23.9 cubic centimeters. I think this is a much easier rule. Hopefully you will too. Figure out how many sig figs are in each number that you are adding or, multiplying or dividing. The smallest amount of them is what your final answer can be in. Now we're rounding to the amount of sig figs, not to the place. Okay? All right. So the density of an object has a mass of 32.566 grams. The volume of the object is 22.70. By the way, if you use the balances in the back of the room, this is how your mass would come out. If you use most of our graduated cylinders, this is how it would come out to the tens place. So this is not an unusual calculation. How many sig figs in the top? 5. How many in the bottom? So how many can your answer have? 3. That's it. Which digit is the 3rd sig fig?
3.
The 3. So we are rounding it in that place, or in that digit right there. The number after it is a 4, so what do? We leave it. 1.43 grams per milliliter. By the way, these 2 problems are very indicative of what you're going to see. What I mean by that is, if you're using a ruler to take measurements, they should all come out in the same place. That is why that first measurement, they all had 3 sig figs. They were all to the same place. Here we are using 2 different instruments. We are using a balance and a graduated cylinder. They probably won't have the same amount of precision. And that's why when we get to our answer, we have to round it to the correct number of sig figs. Questions? All right, I'm almost afraid to ask, but are the 2 on the bottom on this page multiplication or division for you? Oh, I got that one right. Okay, punch them into your calculator, and I want to know what we get out of our calculator. So please don't everybody start with the first one. Somebody start with like the last one or the second to the last one, because then we can get the answers up here a little bit quicker. Evelyn, you got one for me? This one?
So 3.96 463.
Okay, hold on. 3.9646.
34146.
A lot of digits, right? And a matter of fact, a lot of useless digits. But again, that's what I wanted. I wanted you to give me what you would get out of your calculator. All right, somebody got another one.
10.19
Shining, I'm sorry, which one?
for the division.
Okay.
10.19090909.
Like that?
Yeah.
Okay. Thank you. Anybody have one of the top two?
I did that one.
That one. Okay.
Your mouse is
Okay, thank you.
0.4389.
By the way, what do you notice I do with the units in a division problem? I combine them and I just put one over the other. Grams per milliliter, meters per second. In a multiplication, I just simply leave them there multiplied together. Okay? All right, what did we get in this first one, please?
67.0516.
The unit on this one is meters squared because meters times meters would give you meters squared. Okay? All right, now we go to our rules, ladies and gentlemen. The rules say how many sig figs in this first number on the top here, 21.56? 4 sig figs. How many in the bottom number, 3.11?
3.
So how many can your answer have?
3.
So I need to round this to 3 sig figs. Rounded to 3 sig figs, what does this number become?
67.1.
Meters squared. Very good. Questions? All right. How many sig figs in this top number here? Kilograms, 0.33. Nope.
Whoops. 2.
2. The 0 at the front does not count. How many in 1.330? 4. How many can your answer have?
2.
Only 2. So when we round this to 2 sig figs, ladies and gentlemen, here's the second sig fig. What's our final answer?
0.44.
Kilograms times meters. Questions? 16.255. How many sig figs? $16.255. Go ahead. 5. How many in 4.1 milliliters? 2. Final answer can be in how many? 2 sig figs. Okay? So when we round this to 2 sig fig, the 9 is the second sig fig. What would our answer be? 4.0 grams per milliliter. Okay? All right. Top number, how many sig figs? 1.121. Somebody. 4. Bottom number, 0.11. How many sig figs in our final answer? 2. Where's the second sig fig in this number?
0.
Okay, so how do I write this? Like that? Because what's wrong with this? And right now, how many sig figs? 1. How do I make the 0 significant? Put a decimal after it. You can do this. Unit meters per second. Questions? I know that looks weird. I know that looks unusual. But you can do that. Okay? You can do that. Questions? By the way, this is really important, the fact with this decimal, for sometimes when you're taking measurements. You may be looking at a thermometer that's marked off 10, 20, 30, 40, 50, 60. What place is that thermometer reading, and if those are the only marks? Which means you can go to the what place when you report an answer? The ones. What if the level is right at 20? Well, if you write down 20 degrees Celsius, what place is that to? If you write down that number this way, what place is that to? No. The tens. That 0 is not significant. There's your last sig fig, correct? So how do I make that 0 significant? I could do this. Now it reads to the ones place, correct? Okay? So be careful. Do you want that 0 to be significant or not? Here, the 0 is not. The tens place is the last sig fig. Here, the 0 is. Anybody got another way of doing that measurement without putting a decimal in? Could you do that? Could you estimate that it's 19 instead of 20? Could you estimate that it's 21 instead of 20? Your choice. If you choose a number like this, though, 20, 350, okay? And you have to decide, should that 0 at the end be significant or not? If you need it to be significant, you got to put a decimal in. Okay? If you want 350, the 0 to be significant, put a decimal or choose 349. Nobody's going to argue with you. Okay? Questions? Okay. You have got, ladies and gentlemen, about 10 minutes left to the hour. 12 minutes because my clock is a little bit fast up there. Here is an entire worksheet where I had asked you or I had told you if you were doing this worksheet to just put in the answers in this box that you would get out of your calculator, correct? Well, here's your chance to be able to round them, okay? So in this first problem, ladies and gentlemen, which of these three measurements is the least precise measurement? Which of these three is the least precise measurement out of the three? 16.2, which means that this is the 0.2, which means your answer has to be point something. One digit after the decimal. Take the number that you get here out of your calculator, round it to the tenths place. These three numbers are being multiplied, correct? What's the rule for multiplication and division? What do I look for? How many sig figs? 12.33. How many? 5. 0.236. 3.250. How many can your answer have? Your answer can only have 3. Again, using the rules we just taught you, ladies and gentlemen. Go ahead. All right. So you have got actually 2 worksheets here where you can do this. Okay? 2 worksheets there where you can do this. Evelyn, you're going to be the first to try today. Go ahead and type in your ID, and we'll see if that works. Give it a shot. And it doesn't. Close that thing down. Just close the whole cover. Hang on, Evelyn. Go ahead. I'll make one for you while you're gone.
Frank, can you do me a favor? Can you go to Anthony campus and
Answer when you want to.
Because I'm not playing off. Because
When you get your answer, you're gonna
no, because when I choose, I feel like it's not one. You know, I'm gonna say so I'm not gonna change my voice. I'm not gonna change it.
So you just put the whole
Yeah, no, we'll
Where?
Oh my god, the second video. It's like,
You click on the menu there. Yeah, that.
it sounds like, it was like the way he says it. So. There's a cutoff for it. All right.
So as your teacher, in class that you're in, my name is.
No, I don't really understand.
You basically got
Yeah.
My whole game says
It's
all
all
this is really good, so I'll just do it.
Thank you very much.
So that's what my mom says. She was like, oh yeah, next, no, like 2 years you can start over. So I'm like, just leave it up for it because I don't understand it. I'm like, well, no, because I think they use like so, like, just let me know. I am gonna love, so I can get those stickers.
But if it is above 5, then you're gonna do
Why? I think I would make, I think I should be, because you're actually kind of good at it.
What do you do for multiplication?
Okay, I don't know why there is.
Multiplication and division, you bring multiply for the multiplication.
Like, just get up and start.
How many 6 are in each? So,
Because we got a freaking.
5, 6,
So like, I think that American so.
okay. How many are
Because
there?
it was some stuff like versus shit.
Yes,
Right,
great.
like, secondary.
Remember, because I bought it and I'm less than that. And then how many are there?
Why are you wearing watch?
So, your,
Wait, where's your
multiply them.
I counted that zero.
First, you ask the other the numbers,
Are
are
they
they
empty?
answer that?
Because the one that you see like that is what I
Oh, I
Not an
Can we round this?
It's work.
I can't round.
Because we have to run it.
Sorry, Ray.
Because there's, you know how like to the place, and then I've been doing 6.
Yes, right.
Okay, so it doesn't matter
100s, yes. So what would that number be rounded
where
to?
it
100.
is, but you're still
Okay, where's the 100?
Wait, what?
Okay. So, but we look at the number after, right?
Smallest number has
Which is a
to
7, which means instead of a 0, we would
So
do
this
what?
matters where that is in your number.
So that would round up to?
Well, like, I was thinking like, let's say,
No, it's just 100. So it's kind of like saying, you know what, the cost of the car is $24,999. Actually, $5,000, right? You could just round it. That's what you're doing. Okay, so since it's almost $80, let's say, you would round it up to 100. That's as close as we can. Doesn't mean it is actually, but it just means it rounds. No, you don't have to. Now when you round to 10, now what's that become? And then when you round to the ones,
This one isn't rounded up to this place.
so let's do the 10. So 79 rounded to the 10 would be 80.
If you're on
79 rounded to the 1 would be
When you average
Now, all three of those are fine ways of expressing that number rounded to those places. Now, not real precise, a little bit more precise, even more precise. Okay?
Does that make sense?
So that's all we're doing is practicing rounding. Okay?
I understood the end element, but times in
If I do
I
that.
kind of just.
Okay, do you want me to do another one? And then subtraction is just the same as division and, or as, oh my
As
goodness.
adding.
Addition,
Yeah,
yes.
I should just make.
I know my numbers, I totally know it.
Wow, I can't believe this.
Oh.
Girl.